Okay, now working on question number 5. Table shows the number of customers X and the takings Y recorded to the nearest £10 at a local butcher's shop on each of 10 randomly selected weekdays. The first 6 pairs of data values in the table are plotted on the scatter diagram shown on the opposite page. We're asked to plot the final 4 pairs. Final 4 pairs are here. Now, I've already done this here to save time, but this is another question where I would really suggest for 1 mark at A level, if you're being awarded marks for plotting points on a scatter diagram, please take great care. Just have a couple of practices along the x-axis and work out what the scale's going up in, and do the same for the y-axis, the vertical axis. Quite often the scales will appear to be similar but will be slightly different. The examiner will place a transparency over the top here, and it will indeed make sure that your points match the points on the mark scheme, so just take care. So that's very straightforward for 1 mark, but plot the points. I've done mine in pen so that they come out clearly on the video camera, hopefully, but you must use a pencil. You'll only get 1 go, and if you make a mistake, it's very much more difficult to rub out pen than it is pencil. Part B, part 1. Calculate the equation of the least squares regression line in the form y equals a plus bx, and draw your line on the scatter diagram. So I need to go back into my calculator. Again, you can use either the graphics calculator or the old school calculator. My preference, I have to say, is still with the old school calculator, and I'm going to go back into the same table that I used earlier in the paper for calculating the PMCC. And again, I'm going to take great care and entering my values. 86, 60, 65, 46, 71, 93, 56, 81, 75 and 57. I've entered all my X values. There are 10 of them. I'll just check very carefully that matches the 10 that I've got there. So now the corresponding Y values are 940, 790, whoops, no, I nearly made a mistake there. So clear, let's try that one again. 790, I forgot to press enter. 620, 530, 770, 1050, 690, 780, 860, and 550. And having made 1 mistake, I'm just going to make sure that I've entered all of those correctly. 1050, 770, 530, 620, 790, and 940. And again, I would sincerely suggest you do exactly the same. It's so easy to make a mistake. There are 6 marks available for this, in turn with us drawing it afterwards, so we really must take care. Okay, I'm going to go back and ask our old friend Reg to help us with this. So I'm going to go to number 5, and I'm going to call up first of all the value of A, and my value of A is 67.65. So for the purpose of doing this, I'm going to use 67.7. The value of B, again I need to go back and ask Reg for help with this. Number 5, number 2 is 10.0. So it's quite nice and easy to work with. So 10.0, and I always like to write that in the form y equals a plus bx. So our equation is y is equal to 67.7 plus 10.0 lots of x. And the next thing that we're asked to do is we're asked to plot that. Now I have to say that I use my calculator again to help me with this, and what I do is I pick 2 points that are at quite extreme values on my chart. So what I'm going to do is I'm actually going to use the predictive function for 40 and 100. And what that tells me is it doesn't give me an observed point, but it tells me what points the calculator and my line of best fit that I've drawn, my least squares regression line, y equals a plus bx, would give me a predicted value for when I had 40 customers and when I had 100. So I'm going to key in 40. I'm going to go back, shift number 1, going to go back and find reg. I'm going to key number 5 and I get 40 y hat on the screen. Sorry, show that on the screen. And that gives me a value of 467.85. So 468. Realistically, I'm probably going to have to plot that at 470. I'm not going to be able to get any closer. I'm going to do exactly the same for 100. So I've keyed in 100. Shift number 1. I'm going to go to number 5. I'm going to press y hat, which is number 5, and that gives me a value of 1068. So again, realistically, it's going to be difficult for me to plot that exactly. So I'm now going to plot those values. I'm going to plot 40 and 468. There's 450, 460, well, 468 is going to be just below 470 there, just a tad below 470. And I always put a little circle around that to show it's one of the points that I've calculated myself. I'm going to go from 100 up to 1068, so 1050, 160, 170, and again that's going to come in just under that value there. And I've put a circle around it again. I think they're visible. Then with my ruler very carefully, I'm going to join those points, the ones that I've identified in the circle, and I'm going to go right across my whole graph. And that's my least squares regression line. Plotted on the paper. So that is my 6 marks for B part 1. In B part 2, and I'm going to try and keep my work on this one page just so it's visible on the camera, it asked me to interpret the value for B in the context of the question. Well, B is the gradient of the line, it's the slope of the line. So what we're doing here, we're going up in tens along the bottom, but the gradient here, this value of 10, would be the increase in the y variable. Now on the y variable, it's the takings in pounds. So it's the increase in takings, and I'll put in brackets there, pounds, for every additional customer. So we always put that in terms of unit increase on the x-axis. So basically what we're saying here is for every x value that we go along, for every 1 that we go across, for every extra customer, our takings are going up by £10. And it's as simple as that in the context of this question. And that would be worth 2 marks there. State why your value for A has no practical interpretation. Well, the value of A here, 67.7, is essentially the takings if we have no customers. Well, if we have no customers, it's unlikely that we're going to get any takings. So it's the intercept in terms of the graph. The intercept is when we have no customers. So this would not be a practical measure with respect to takings. So we can't actually, I mean, if we're running the shop, we can't actually have any takings if we haven't got any customers. So that's that part done. Final part C. Estimate to the nearest £10 the shop taking when the number of customers is 50. Well, again, we're going to use the calculator and we're going to do it just as we had done for when we plotted the line. If we'd been really clever here, it might have been that we could have plotted the point for 50 and done our 2 jobs at once, but never mind. So 50, shift number 1, number 5, and number 5 again. And the predicted value there is £567 and 90p. I'm just checking here that it's not in thousands of takings or anything other, because sometimes you've got to be a bit careful of that, but it is there. Now, it did actually ask me to estimate to the nearest £10. Now, I would always make the answer that the calculator's given me quite clear here, and I did that by doing 50 y hat, so I'm going to leave the examiner under no confusion here as to how I've got that value, but it's asked me to give it to the nearest £10, so to the nearest £10, I would estimate that for 50 customers, the taking is going to be £570. I'll have a very quick read through the question, but that concludes question 5.